And if you have this event, if you wanna put your name, so people don't struggle to call you like you. I always, if I don't know, I struggle with that. If the name of the people, I must struggle how to call them. So this event is streamed on Dev Tag Planet. Here are the cards you can grab. There is also address, and I will talk in a second more about it. As I said, we need speakers, especially aspiring speakers. So if you wanna try your, like speak for the first time, this is a great start to place to start. And we have like at the start of the month session when we have like 3 aspiring speakers, which was great success, and everybody enjoyed that. And we have 2 of those people who spoke over there as well here today. So this QR code is actually to, I think, to sessionize. So yeah, but this is a big announcement. Yes, as I say, I'm still part of LJC. A lot of us are still part of LJC, but we decided to move these events to new place for different reasons. But that will be a new chapter. Everything will basically stay the same, but we will just be kind of like taking full responsibility of running those events. And who knows where that leads us, yes? So I hope it will be even better than it is now. So our current focus is to make these events better. As I say, there is a lot to improve. And I hope that a lot of people on this who's sitting here will be part of it. Because I want to make it community run by actually members. So yeah, if you want to be involved in more capacities than just only attending, just let us know. And it will be based on meritocracy. Yes, the more you do, the more, let's say you will have in the community. Yes, not on the past glory or whatever, which sometimes was the case in LJC, yes, but just what you doing now. And everyone is welcomed, no matter the experience, tech stack, gender, race. We want to be very inclusive, sorry. I think everyone has some story to tell, yes, and every story is interesting. You just need to go and tell it, yes. So I want to be that place where everyone can tell their stories. So yeah, it started like announcement I did like a few days ago on LinkedIn, yes. But we already planned the first event under this umbrella. Will be 11th of September. So stay tuned. Yeah, the more details will come. But as I say, we not departing completely from LGC. I'm big. LGC is big part of me, and I will be still involved. So 29th of July, there is another roundtable. So please enjoy this place where we just sit around the table and discuss things tech related. Most likely will be again about AI. And in August, we will have NCAT with the event sponsored by Redis. Redis looks like they want to be involved more, which is great for the community. And kind of like last but not least, sorry, is the supporters of the community Records, which is recruitment agency, which is actually behind the LGC. And yeah, they for over the years they could do the great things for the community. Yes, and if you look for job, or even better, if you're hiring in this market, just give me a shout, and then I will contact you with the right people. And Couchbase, which is our house, again, without companies like Couchbase, there will be no community, because where we will host those events. Yes, so big round of applause for Couchbase for having us tonight. And I already speak with Anna, and I hope we continue our collaborations on the new name. Yeah. And there is the last slide with probably for the last time, because we won't be affiliated anymore with LGC. This is our LGC sponsor, so give them a shout. Yeah, they fill the important role as well. So that's really it from me. Should I say something else? We have
yes, because maybe this is another what we need. We have something like a mock interviews, and with a very small, we even a people.
Verissimo is sitting there, so yeah.
You want them? We was one together yesterday. It was a good, very nice, and I recommend maybe because I know this market is not well at this moment. Life change, and it's a good to make us something similar like a training before when you want to change your job. Yeah.
I think you have to move camera, because now I'm standing here, and I'm not a camera. Just saying. Okay, that's all for me. Sai, is your turn.
Okay, thank you.
Do you want to connect? Yeah, if you want. I don't think we will. What happened? Probably you have
Oh, you can see it. I forgot the HDMI cable. So if you all want to join me here around the booth, that saves me unplugging in a cable. It should, yeah. This should be it. I think so. Oh, sorry, it was. Are there any questions?
Why it's not working?
Oh no, it works.
Yeah, it's something like that. It's working. Smart.
Yeah, it's smart, yeah. It's an AI-driven television.
We've been there before, so
Cancel that out.
yeah.
Still works. That's what I get. You need to register an account. I think it's the TV asking for an account.
Yeah, we're back.
Oh, just already? Okay. Nice.
There were instructions actually.
Oh, what? Ah,
Don't touch it. Let's just walk out this far.
I'll be standing here, not touching anything. Okay, can everybody hear me? Even in the back? It's okay? Okay, great. Well, first of all, it's really great to see you here. I'm really happy to be invited. It took us, I think, about a year. Once I submitted my session, and then we had a contact about a year ago, and now finally I'm here. And not with this session, so I changed session a bit. So I hope this sounds interesting, at least. So in the next 45 minutes or so, yeah, I want to do a bit of a thought experiment, similar like Schrödinger did. I don't know, is everybody familiar with Schrödinger? He's kind of a cat in the box thingy. We won't be that cruel in this session, so we keep it a bit more clean, I guess. Yeah, and that I want to do a bit of similar experiment. Let's see if this thing works. Ah, it works. A bit of a fair warning. We do some live demos, and it received some updates. It's really true this time. Sometimes I just fake it, but in this case, it's really true. So yeah, we have to see if the application or Schrödinger's app is still working or not. So that will be the next step. So, and the only way to check if it works is we have to measure it. So we have to open the box and see if it works. And I want you to show just our demo application. It's also on GitHub. So if you want to follow along or see the code, you can find it here. It's all open source. I will show you another tool as well, which is also open source to make it work. But it's Comify, and it's a comic-based social media platform. And if you have read the description of this talk, then we are going to talk about monoliths and microservices, etc. So I will start Comify first and show you what the app is, and then we go into depth. Oh, I don't think this needs to be open. Okay. Can everybody read the text, or should it be a bit bigger? From back also, okay? Okay. So I'm running the app in standalone mode, and that's it. It starts something, and if everything works, I should go to localhost 3000 and I have something like Comify. So this is basically what it is. You just take a picture, add speech bubbles, and you share it. And we can log in. And I take my default account. So I made your banana. I don't think that needs any explanation. So and basically what it is, yeah, I think it's quite a default setup for a social media. I don't know if you're on social media, things like Blue Sky, whatever. You always have something like suggestions for you. And you can follow users. The users we call creators. That's something to just to know and to remember. So you're following for you. So you, of course, you have some explore, so you can find new creators, and new comics from creators. And of course, the most important one. Now I have to stand here. I can take a picture. I've practiced hard for a summary for this talk that I want to place here. I think this is pretty spot on. So now we can just move this and hit create. And now just like any social media, I can like my own things because nobody else does it. And you can add reactions. You can do a comic or a reaction. Like great. And of course, I've made it myself, so I like it. So, okay. So that's basically it. You have some notifications, which will come back. And of course, you have your own profile, your own things. So I hope this gives a bit of idea what the application is. And of course, we assume that once we go in production with this, that the whole world will start to use it. So at some point, it needs to scale. Probably we have 3 users, but that's not, we'll see. So that's the Schrödinger's app for now. So now we have done that introduction. I will briefly introduce myself a bit. Does anyone watch Emily in Paris? Nobody? Keep it that way. Okay, so I'm Peter. I look like no one. I'm really unique in this world. So I'm the co-founder of Masking Technology. We're basically just a small consultancy company. And what we do is we try to help other companies to become more cost efficient in their software development. And we do that by future-proofing them. So meaning you build an application and you try to last as long as possible without continuously breaking your application and heavy refactoring, etc., etc. So that's what we do. I'm a software architect, but I'm also a full stack developer. So I have a strong background as full stack developer. I basically haven't done anything else in my life. So I do this for almost 25 years, but 20 plus years just makes me feel less old. I have the strongest background in Java. But I've also worked with C#, PHP, some Python. But in this session, already mentioned, I'm trying to brainwash you into TypeScript because, well, that's how we build the application. So I hope that's okay for you. Who has some experience with TypeScript? Who would consider himself full stack? Nobody? Front-enders? No Java front-enders here. Didn't expect that. Okay, so for the most part, backend. Okay, so this talk mostly focuses on the backend because it's mostly backend architecture related. So I think you all should be fine. And the things you'll see here can also be done in Java. So keep that in mind. You don't have the tools yet, but the same tricks can be done in Java, and it could work the same in Java. So, and in my spare time, which I don't have because I have 2 small children and a wife, I don't know which takes more time, but I like to make illustrations, but I'm not really good, so it's just for fun. So don't hire me. So as I said, we focus on future-proofing and making companies more cost efficient. So the whole Schrödinger's app idea also comes from that focus that we have. So if you look at a lot of companies do research on challenges in our industry, well, and I think it's pretty clear. So there's a company called Good Firms that works with a lot of software houses, etc., and often ask them what their biggest challenge is. Well, the big blue thing says their biggest challenge is currently adapting to changing client requirements. Is that recognizable? So basically dealing with change, because the change is constant and you have to refactor your application just to deal with the change. So, and then if we look at how we tend to build applications, so we always use the Lego example here. So we tend to build components, put them in modules, and just stack them upon each other. But at the bottom, there's always a bottom plate which holds the whole structure. And that is, in essence, what we see is the architecture of your application. And above the bottom plate, there's the data layer, there's the business layer, and there's some application layer, or maybe your presentation layer, or whatever layers you tend to use. And if you look at the impact, so if you only need to update a view, well, the impact is not that big. If you need to update your business or your domain a bit, your business logic a bit, that could impact your views a bit, but you still should be fine. But I think you may have already experienced that if you touch your data model and do some big changes there, then, well, it becomes harder and harder. And so if you would touch your bottom plate, so basically your architecture, then most situations I've seen just started over from scratch because it was just too fundamental and was too hard to change. Yeah, and that's what we like to avoid. So, and if you look at modern architectural uncertainty, so who here has had some kind of debate whether it's better to build a monolith or microservices? Okay, you almost half of the room. So who here is building microservices? Those are almost the same hands. Can I say safely assume that the rest is building monolith? Okay. Also some hands for a monolith. And what we see, I think there was a great article about almost 2 years now, I guess, from Amazon Prime, from their monitoring services. They started out with microservices, and well, their infrastructure costs were so high because they needed low latency. And then some genius came by and he said, why don't we just put it all back in the monolith and lose the latency? So they put it back in the monolith and they saved up till 90% of their infrastructure cost. And now with that, we see, if you look at sources like Reddit, but also other articles, you see more back and forth ships between the monolithic architecture and microservices, because of course you can start with a monolith and then slowly refactor to microservices, but that is still in some context quite a lot of work, because you still need to think about the communication. So if you split things off, you still need to distribute these things, and these things are still complex. So it's still not that easy. But we see that there is a growing need in that back and forth, meaning what you want is just you want to build a monolith and be able just to split off the part of the application that, for example, experiences high load or needs some fault tolerancy. And once that need is over, you want to put it back in your monolith again and just deploy it in the most cost-efficient way. So, and how would you do that? We've thought about it. Actually, we gave it some thought for a while, and we came up with a standard solution. As engineer, you like to separate your concerns. So, and we saw that there was some separation missing, and that's basically the separation of your development model. So the way you would modularize your application and build your components and how to organize that and how you deploy it. So basically the things you would actually put on the servers. Because now, if you want to deploy services, you have to build these services in your application. So that means your development model and your deployment model should align. Otherwise, it wouldn't work. But that gives a lot of friction, and it makes it a lot harder. It makes it harder to be flexible in your deployments and in your development. So by separating them, you find, okay, but if we manage to do that, then we can create what we call a just-in-time architecture. So you just, as I said, you just build a modular monolith, and just by configuration, so not touching the code or whatever. By configuration, you just say, okay, you know what? This module and this module we place together on server A, and that module we place on server B, and that module we place on server C. And well, if in server C we can just scale out and load balance, etc., etc. And that makes things way more simpler, we thought. So once we figured that out, that is something at least we needed also for a project. Then yeah, we were kind of okay. How are we going to do this, and how are we going to build this? Are there tools for this? And at the moment that we started, there weren't any tools for this. So long story short, we built our own. It's also an open source project. It's called GTAR, which is an abbreviation of just-in-time architecture. So of course, Comify is running on GTAR. And what it is, it's just a runtime. So we've built on Node.js. So for the people that aren't familiar with the JavaScript ecosystem, if you want to run JavaScript on the server, you basically use Node.js. There are others, but they are smaller and still compatible with Node.js. So we built a small layer on top of Node.js for the distribution part. Also on GitHub, it's free, it's open source, so you can take a look. So we needed a tool, but then you have the tool, but still your application must meet certain criteria before you can actually split it without breaking things. And the first thing, of course, is your application structure. So I think we are becoming more familiar with building monoliths these days. So we're building modules with strong boundaries. So that means they're depending less on each other, which is absolutely a good thing. So that is what we, of course, did for building our own monolith. And we start to use vertical slicing. And in this sheet, it's just on domain, on subdomain level. We'll see that Comify does vertical slicing even on feature level. So it goes even a bit further than this. But we still do some layering. So like the persistence, business logic, etc. So each feature with us has all these concerns, all these layers together in a feature that works. So that's basically it. So that's what we started to do. But of course, every component also needs to meet some criteria. So if we look at a building block, so we see a component, just a simple building block. Of course, for the most part, it should be completely stateless. So most components, there are exceptions here, but we also try to keep every component just stateless. Because if it keeps state and you start distributing it, so if you haven't experienced it yet, you might can imagine that things go boom. And we want to avoid it. So to keep things stateless, I think that's best practice anyway in any kind of application. Another thing is that all the communications should be async. So that means if you do a function call, you should await its results before continuing, because, well, if you call to another function or class or whatever, should be made replaceable with a remote call. Otherwise, it breaks. It's as simple as that. But also, so we're talking here about the code, but there's also a big part, of course, of the application that is in the database. Mostly refactoring or scaling an application is kind of doable, but then if you look at the data, then it becomes harder. So if you look at microservices patterns, so they don't use any relational integrity in their databases, because all the tables or collections or whatever you are using, they should be movable. So that means that all the relational work should be done in the application and should be get out the database and just moved here. So that means if we have joins for retrieving data that belongs together, we should create components that do the aggregation, so the joins in the code. And that makes it easier just to split up your database with your code and create microservices dynamically. And of course, if you have to do that for the reads, you have to do something similar for your writes, because if you want also start splitting your database with your application, yeah, then your writes are also scattered over the place. So you need some replacement for your transactions. So basically meaning everything succeeds or fails together. And I think the most common strategy used is the Saga pattern. If you're not familiar with it, I will show you later in the code how we do it. So that will explain, I think, how it works, and it's fairly simple. And of course, and I think you are all already doing this in any application, because this is, I think, also a best practice, immutable data. And I think Java has become very good in immutable data. When I started with Java and building scaling systems, they didn't have the record type, for example, so it was a bit harder. But these days they are absolutely better. So yeah, so now we have the building blocks. So if we look at the application structure and we combine this with these building blocks following these rules, that enables two things. A, we can split vertically, so we can split off our vertical slices. For example, if our notification system experience high load, for example, then we can split it off, scale it out, load balance it, etc. And we can do that without breaking things. But we can do the same thing for the persistence. So for example, if you want to add a security layer around your persistence, around your database or anything that touches the database, you just can split off all your persistence components, so basically your queries, yeah, and just add some protection, or even load balance them if you want to. So, and that is what I want to show. So this is exactly what we did in Comify, not because we need it already, but well, we needed some demo. So what we did. So Comify, we are going to dive into our code base. So it's a monolith, I will show you, but we have created what we call 4 segments. So we split it into segments because the segments aren't modules, because we have a module per feature, but they aren't services either, because they can be deployed together. So there's something in between. They're just a layer above your application, some additional meta layer. And we've created a backend for frontend. Who has heard of the backend for frontend? Okay, just a few hands. So what it means, Comify is full stack. So in our monolith is also the frontend, is the UI. We built it with React. And of course, that UI needs the data, and it needs the aggregated data. So already prepared for the use for the front end, so that the front end don't have to do the aggregation, all the complex conversion stuff. It's only BFF, it prepares it for your front end. There's the logic. So we created, so I will put that all the BFF features basically in just a BFF segment. So it does the aggregations and the sagas in this case. So it orchestrates all the processes. So we split up the notifications, so that's a vertical split, and we split up the reads from the writes. So that are the horizontal splits, and we can see that work. Questions so far? Still interested? Okay. Well, let's dive into the code and let's see something. I need to stop this first. I always forget to stop it, and then I start another server and it doesn't work. So now I will stop it. So first, I will do a build. So I can do npm is the node package manager, and I can add actions there or scripts. And I need to type build instead of build. And I just want to show you something. So again, this leverages gtar, and what it does, I will show you the configuration once I have showed you the code. But it builds the segments. So what it does, it splits the application and it creates distributable bundles. So it's just one package you can pick up and you can just deploy on your server and you're done. So that's basically it, what it does. So that's the end product. So these are the segments, and I can run them independently. We've already seen that I've just run it as a standalone. So that means it has created all the segments, but it has combined all the 40 segments into a standalone solution. So ideal for development, so you don't have to spin up all your dependent services on your machine. So you can just spin up everything at once. So that makes your development and testing way easier. And from there, I can start some other services. And then I kind of dislike microservices for their complexity, because you also need a lot of additional services. In this case, we only need 3. So we need a repository, which is basically acting like a web server now for the client, because we have a web client. We need a gateway, because, well, we have these segments and our modules are just scattered all over the place in the segments, or the gateway knows which feature is on what server, basically. And we need a proxy for the web client that combines the repository and the gateway together, so we don't have any issues for our web clients, basically. But if you're only doing backend stuff, you won't need it, and you won't need the repository either. But once we have these things running, we can actually start our services. So we've created a BFF service. We have created a notification service. We've created a read service. And we've created a write service. And what I want to show you is this should still work. It still works. And now I'm going back, because if we look at, I'm first going to show you what we're looking at. So for the writes, for example, so these are the writes. And if we start a service, we start gtar. We made it quite big, I guess. I'm not sure why. It just looks funny or so. So it starts a server, and it's what it does per module that is placed inside a segment. It tracks its functions, basically, and it creates an RPC-style endpoint, so you can run these functions remotely. So here, if you see how we have built it, so we have some domain logic for the comic, and it has a create and it has an insert data. So that means that the insert data, in this case, the function is a part of the write segment. And we do the same for the erase from the comic, the create from the comic, etc., etc. So these are all the writes. We have the same thing for the reads. So these are all the things that are registered. We have the same thing for the notifications. That hasn't done anything yet, because I haven't touched the notifications yet. So if I will click on the notifications, you should be able to see that it has got the recent notifications. We have requested them. We should also see for the writes, for example, if I would have something to like or dislike. I will dislike this one. It wasn't funny anyway. So now you see that when I press the button, so at the write service, it has erased a rating, and it has updated the post metrics because the number of likes is decreased by 1. So that is basically what it does. So it's really segmented. And of course, if we look at the reads or the BFF, then we see that that a lot of things happened. At least you see here what I already clicked on. So it did a login. It fetched my own account. It got the recommended post, and these are all the aggregated versions. So I think with that, it's time to dive into the code. Just to be sure, how much time? 15 minutes left? Okay. That's still okay. Let's first go, since we're mostly backend developers, is it okay if I skip the front end, or do we also want to see from front to back? Who wants to see front to back? Oh, okay, quite some hands. We do front to back. Okay, so first, our basic setup. So if we look at our source, I think this can be one bigger. So if we look at our source, we have just four folders, and the publicly available assets are our domain logic, basically containing our subdomains, and per subdomain we have all the features we will dive into later. We have the integrations, so all the stuff you need to make your domain working but don't want to have in your domain. Things like your actual authentication implementation, the way you work with the database, your event broker, file storage, etc., etc. And of course the web UI, which is the front end. And let's start with the for you. So that is this one. So if we go to this feature, so we do feature-based routing. So every route ends up with a front-end feature. I think I can close this one, and maybe even close this one. I think this gives a bit more space to see. So if you've never seen React, does everybody has a bit of experience with HTML, or at least seen HTML, or maybe XML for that matter. It basically looks the same. So React does the same. So you just create kind of HTML tags, which are just converted to web components, which you can use. So we have a column here. We have a pull to refresh, because it's also a progressive web app that you can use on your mobile phone. We have a scroll loader, so if you just scroll down, that it loads more. We have a result set that just shows we have found some results, or we didn't find anything. And here we have a post panel list, which is the component that shows the list with all the posts. So that's basically it. And this is a feature because it composes all our components together with the data that we load from somewhere. And in React, all your interaction logic and your data loading is done in hooks. That's what they call. So here we have a hook that gets the posts, and these posts we just pass them through our post list component, and it will display these posts. And if we dive into this hook, what it does, you use some caching in React to prevent re-rendering effects. So we just use a callback. That's not important. This is important. So here we have a get post recommended. And if you look at where it's imported from, so this looks a bit similar like Java. It's not exactly the same. You don't have packages. You have modules here. You have, of course, also modules in Java, but these are a bit different. It's a bit of a different system. This is coming from the domain post get recommended aggregated. And if I jump to this, I'm jumping actually to the backend code. So that means that we can just import our backend stuff from the front end, and we don't need to build our APIs ourselves. So basically, what Jitar, our tool for us, does is it does the API automation, which enables splitting your domain also in multiple services. So it knows where things run, and it knows how to find it. So that's why my business partner Bas is walking around with stop building APIs on his back, because, well, Jitar basically automates that for you. Makes it way simpler. So this is our backend function. To prove it, I can show you that we actually jumped to the domain post, to the feature, get recommended aggregated. So we do a procedural approach here. So because that really fits with the conversion for the RPC style communication, that that it uses, and it simplifies for us at least building workflow-like applications. So we don't think that most applications actually need OO. So what we did, we have a simple function. It's of course an async function, and it's stateless, so it doesn't keep any data. And in this case, it just validates a range. It gets the actual data from the database. So it's, in this case, it's accessing another feature. And this feature, so this is the query under the hood. I'm not sure if I can say it out loud here, but we use MongoDB. But this can also be done with Couchbase. So you know. But this is currently we use MongoDB. So this is just a query. So that means this feature is segmented on the reads, while this aggregated feature is segmented on the BFF because it's used by your front end. So it gets the actual data. It's just non-aggregated data. So it only contains IDs to the actual creator, to the image, to etc. Everything that a post includes. So and from there we have an aggregate feature that does all the loading for everything that belongs to a post. So if you look at that one, then we can see it's also async function. What we do is we fetch the relation data. So that means I, as a viewer, I see a post of Bas. So am I following Bas or am I not following? So should I add the follow button or should it just display you're already following him? That's the relation data. It fetches if you have rated the post or not. It gets the comic data if it's a comic. You can also use text, so it fetches the text if it's text and gets the metrics that you need, and then it returns simply just all the data in a simple, in this case JavaScript object. But we did a simple trick which you can do in TypeScript to make it immutable. Let's see how this looks, and we also do the same for our database data. We just make a type, so that's why it's TypeScript. You can define types, and you just say, okay, I have an object, and these are the fields, and these are the types, and I make them read-only. So during development, it's immutable, but that means during runtime, it's not immutable. But it should not be touched during runtime if you do things right. So this is safe for us for now, for immutability. So that's what it fetches, so an immutable object. And then it goes back into the aggregates, and then it just filters all the resolved in this case, because maybe we have some kind of database corruption and everything that it shouldn't or can't fetch for a post, then we just don't display the post. That's some fault tolerance. We don't need it yet, but we've already implemented it. So that's basically it. So this is how we aggregate data and retrieve data, etc. So, and if we go to the creation part, so writing the data, then I go to the create. Let's go to the create with comic, of course. That's what we did. We created a comic. That's also just a separate feature, which is also just a composition of other features. So it basically, it creates a comic, so the thing with the image, and from there, so you get a comic ID, and from there it creates the actual post with the requester, which is the creator, and the comic ID that it created, and optional a parent ID, because it's like a thread-like structure. So if you react on a comic with a comic, you can also treat it as a comic, and you can also react on that reaction as a comic. So it can go deep. So that's it. And if you go, and if you then look at the sagas, I think that's the most important thing here. So if we go, no. Yeah. On the aggregate post. Oh, sorry. Yeah, it was the create image. Yeah, you're correct. So this is the create post. So the create image is just very, very simple, not a saga. So if it fails, it just fails, and then the whole thing should fail. In this case, it creates the data, it validates, it inserts the data. Well, that can fail. That's not something something that if it fails, we just haven't stored anything and it's gone. So so the thing is more here in the publish. So what a saga does, so we have a few steps in our creation process, and what we want to have is that all the steps either succeed together or fail together. So and what a saga does, it just commits everything. So if I create a post and I insert the data, it just saves it. It just, if there's a transaction behind it, it commits it and it considers it done. But once some step in the process fails, you should detect the error, and then you just do rollback functions or undo functions for every step you have successfully already have executed. And in this case, the only thing that really can fail is our publish. So for example, Kafka isn't running or isn't able to accept our event. In this case, it fails. And we think metrics are, so this is currently only used for notifications and metrics. So all the side effects attached to creating a post. But we want that also to succeed in this case. So if this fails, then we just check, okay, is there already a post ID? If there's a post ID, we know we have already stored it, and then we have to do an undo function or some undo action for that. So we do just an erase of that post. So it throws it out of the database again, and it just rethrows the error. So that's basically it. And this way you can just can scale endlessly. So your data and your code. So to close off, I know we have just a few minutes left, and that's the segmentation part. So this is the coding part. But outside of the source, we have of course the tests, but we also have the segments. So here are the four segments. And if you look at the BFF, it's just a basic JSON document, just naming all the features that we want to include in our segment. So in this case, some authentication stuff, because that's kind of related to the front end, for the creator, mostly so the updates, the aggregated retrievals. So and everything is publicly accessible, meaning it's accessible from our front end. And it doesn't say anything about the authentication because we have a middleware in between that checks your authentication and eventually your authorization. So that's just on another level. But this is only to determine, okay, it's coming from an unknown source. This request, can we accept it? And if it's public, it's always, you can always accept it and just execute it. So here we have all the features, and the same goes for the domain or for the notification. The only thing different is that the access is protected. So that means if you spin up your services and your gateway, they are together in a trusted network. So that means you can only, from the front end, you can only access your BFF functions, but you can directly access all your read functions because it's protected and you're not in that protected space. But the BFF is in that protected space, so can access all the other functions as well, because they trust each other, basically. So that's what it says. So the same for the reads. and the same for the writes. And then we have only one thing left for now, and these are the services. So how to combine them? Well, I think let's start at the standalone. There are a few things here. So of course you have a URL, so how it's exposed. We have some setup scripts because you have to connect to the database, etc., etc. And once you shut down your service, you have to disconnect. You have some health checks to see if everything is still up and running, and you have some middleware, in this case for the authentication. But the most important thing is here. So if you configure a service, that could be either standalone or a worker in this case, you can configure the segments it should combine. It could be either one of the segments or it could be a multiple. So our standalone setup just includes all the segments, so it runs the whole thing at once. And if we look at the BFF, it's a bit smaller because it doesn't need to set up everything, but it only contains one segment for the BFF. And here you can see it has a trust key, so that means it is added to the protected trusted space. And that's how you can run things. So you just simply configure it and then run guitar with a certain configuration, and that's it. And it picks up the build distributed bundles that guitar already has created. It loads them and it exposes the APIs. So that's basically the trick that we did. And that is, I think, how you can build a Schrödinger's app. So during development, you just don't know if they are services or a monolith or whatever. It doesn't matter anymore. And during deployments, you just pick a variant that you need at that moment. So that's it. If you want to know more, if you think this is interesting, we have a website. We also write articles about this. So if you find it interesting, you can also find the links to Guitar and Comify here. And you can also find the slides. So maybe that's interesting.
Yeah.
That's it. Thanks.
Are there any questions? Yeah, there are some.
Yeah.
Few, so.
I'm curious how you work or how it is so
Okay, so basically from yeah, sure, yeah. So the question was, so how do you deploy such an application, and how do you integrate it in your CI/CD pipeline? Correct? Yeah. Okay, so basically what you can do, or what we are aiming at because we haven't hit version 1.0 yet, but we want to support Docker, for example. So that means you can create a Docker example for all your services. Yeah, and just load them up into Kubernetes and use the auto scaling for Kubernetes. And then so that also means that Kubernetes should be able to see, okay, this service need to be scaled out and load balanced. So the one thing we still need to build and figure out is how to convince Kubernetes or other tools to dynamically split off a part of the monolith. So, great question, by the way. Hope this answers it a bit. Okay.
In what sense this approach is monolith? So from my observation, I see that it's a single code base.
Yeah.
Let's say it's monolith.
Yeah.
But is there any other point that you consider is a monolith? Because otherwise the system is working as a distributed system or a service system. So
yeah.
So is it only like it's a single code base? That's why it is monolith. Is it the only point, or there are other points? And my next question is that what are the pros and cons of this approach?
Okay, so
any possible drawbacks?
Okay, yeah, great questions. So your question is to repeat?
Why
Yeah. Yes. So why do we consider it as monolith? So, well, the answer is because you just in your code base, you're just directly importing every component. So there's nothing in between. So you don't know if it's going to be distributed, split off, or whatever. It's just one big monolith because it's highly coupled and it's directly coupled. And we just decouple it dynamically by configuration. So during development, it's just a monolith. Yeah.
But we still need to face all the challenges of the distributed system.
Yeah.
There are RPC calls, so one service can fail and you need to handle the use of those. So like all the challenges of the distributed system are there. Right?
Yeah, but you don't have to build the API. So what you need to do, so those are the constraints. Your monolith, your modular monolith, you need to build it in such a way that it's prepared to be scaled at any point. That's the basic only constraint. But you don't need to build your own APIs or think about it, because you just configure them and they will be created automatically from configuration.
Okay, what can be possible drawback?
Well, from the development standpoint, there's a drawback. So if you have a big mono repo, because if you want to scale this over multiple teams, that can be done.
Yeah. That's what actually came in my mind.
Okay.
There are multiple teams working in a single project.
Yeah.
Can I just start for discussions? You know, Peter will be here.
Yeah.
But because we have pizza and we run out.
Oh, I don't want to stand in between you and the pizza.
But Peter is here. I hope you don't mind to take more questions.
No, absolutely not. Feel free to ask. I'm here. Thank you.
Can I say something?
Yeah.
Yeah, testing. Perfect.
Okay. So let's start the second session. Said,
Yes.
floor is yours.
Well, thank you for so much for staying back after eating the food. I'll make sure that either you're gonna sleep tonight or you're not gonna sleep. I have like 4 demos. Are they gonna crash and burn? I don't know. I'm running a development build. I guess we all do that, right? So we want to show new things. So here I am. So my name is Shaaf. First name is Shaaf Syed. I wrote my first line of Java in 1996. This is just, I wrote this so I can relate to you, right? Otherwise, it's going to be difficult. And I've been developing code as a consultant, etc. I write for InfoQ. So there's tons of things that I could share, but most importantly, last 2 years, I've been working with large language models and AI. And so many of you have so many questions, I'm sure. Like most of us, I got into this journey where I said, okay, these are interesting things. What do I do as a Java developer? How do I use it, etc., etc. So I started to get into it, learn it, reskilled myself, if you could call it that. And now I work with a team which is called the Conveyor team. Okay, and Conveyor is an open source project, and it basically what it does is that it has tools to modernize applications. Now, the modernize term or migration term, whatever, we can interchangeably use them. If you're feeling very marketing centric right now and you had good food, I can use the term modernize. If you want to feel like migration, the real thing that we need to do, technical thing, that's the word that we use. So I use it interchangeably, but Conveyor is trying to address this problem by providing, static code analysis, assessments, etc. So a bunch of different things. And I'm part of this team from a developer advocate person. There's a big engineering team that's behind it that we work with. And about 2 years ago or 18 months ago, we started to look into how we can actually use AI to do something, because everybody was talking about it. We actually had a use case that we thought would work really well. So I'm going to show that use case to you today, or the different types of tools and use cases that we built. It would be great if you thought it was nice and you came to the community and started contributing. We are not at version 1.0 right now, so we're still whatever we're doing is in development phase. So I'm going to speak about some of those things, and I'm going to omit some of the other things in Conveyor. The part of Conveyor that I'm going to demonstrate is called Conveyor AI. So it's specifically Conveyor AI, and in short, in our team, we call it Kai. And if you've seen some of the good movies or Final Fantasy or whatever that is, right? So you know what Kai is or who Kai is, right? So Kai has many different meanings. For us, it's Conveyor AI. If you've seen this code, then you don't have to raise your hand. I'll know how old you are. So it is an enterprise Java bean, right? That's what we used to write: remote objects, RMI, IIOP. You see this somewhere in organizations lurking around. It still sits there and people use it. And we want to change that, right? Here's another example of a code, which is the string substituter. If you remember, I think about two years ago, there was a CVE for text for shell, if you heard about that. And basically what it did was that you could execute code directly through JavaScript, respectfully, onto the runtime, right? So you could do that. So by just, like in this case, touching the file, it would just create that, right? So that was a CV. A lot of us were affected who were using Apache Commons. But then the big ticket item came, and this is a very interesting code. If somebody can spot what the problem is, that nobody should actually output the user input in an error. But anyways, so there's basically going to leak the password. But anyways, from a logging perspective, log4shell was also a big item, and that was quite close to Christmas, by the way. So that's I guess a lot of us had fun from the product side. We had a lot of fun fixing things. So we had a really busy time period then as well. So from a conveyor perspective, we want to fix this, and some of the things we do is we do static code analysis. So the first thing I'm going to show you, and I'm going to build this with less slides, I hope, and more of the talking and doing the demo. So what I'll do is I'm going to switch to my demo here. Obviously, let me do that. I hope I put the right password. Yeah. Okay. So so Conveyor has this CLI which is called Cantra, and Cantra is a tool which does static code analysis. So if you're familiar with static code analysis is going to go through your entire file. It's going to try to read it, understand it, and make some context out of it, right? So that's the first step to actually even understanding what the code is doing. There are a couple of tools that are already out there. There's Open Rewrite, there's some other libraries. You can even do this in plain Java. There's in Conveyor we use the language server protocol, and we implement the LSP within this with another tool, and that tool becomes something called Cantra. And the Cantra is a CLI which does all the static code analysis. So here you'll see in my very safe interpolator example over here. There's some code here. There's no syntax in code. There's some different kind of things that I'm doing I shouldn't be doing, right? So for example over here, can you see the code, by the way? Do I need to? Yep, sorry, I always forget that. I have a big screen at home and I always forget this. Sorry, so thank you for reminding. So here I have these, the code that's maybe offending, and I don't want to be able to use it. So what I would usually do is that for Cantra, I would create a rule, and the rule is in our favorite language, which is YAML. I guess everybody's favorite language, right? So that was sarcastic, by the way. So you have a rule ID. A rule ID over here is, hey, there's a replace method. I want you to go check the method call in the location. This is the pattern I want you to look for, etc., etc. And then, as an awesome coder I am, I've written a regular expression, right? So make my life even more harder. And then there are a couple of other, things like this as well. So this is how, the reason I'm showing you this is because this forms the basis of this AI demo that I want to show you later today. So you'll also see a message here which kind of gives some hints around how this thing could be generally fixed. What I'm going to do is I'm going to just run Cantra here. I call the analyze. I call it on my project. And one of the good things about Cantra is that you can also do testing on the CLI as well. So you can actually test your YAML files with writing more YAML files for fun, right? So basically at the end you're able to test it, etc. But the first thing you think about in your source code is you want to build a rule. So I just run this now, and it's gonna look at the target, which is OpenJDK 17 here, which I just put in, and then it's basically just gonna use my rules directory, right? So it's gonna analyze all of this, and it's gonna print out a report. Conveyor by default has about 2,400 plus rule sets that it kind of checks on. So it's not huge, but there are some good rule sets, right? So if I go back to my to my browser here, and I refresh this, you'll see that it comes out with the analysis. In here, it shows like a report, right? So there are a couple of things. It tells me that I'm using an Oracle JDK JPEG image. So when I want to export this or migrate this from JDK 7 plus to another version of OpenJDK, this is going to be missing. So I need to change that, right? I need to change the image format because that's not what I can do. It also goes into my safe interpolator. So in my rule set, I was able to provide some hints and guidelines what's happening in my safe interpolator. Perfect. On the safe interpolator class, I have two incidents which say that you're not supposed to use this SSTI kind of behavior with the replace method. It also gives things like, hey, here's the Apache common text documentation that you can revert to, etc., etc. So it's quite simple. It just does these basic things. dependencies, issues, and kind of gives me this overview, which is great. All of these tools that we know so far today does that, right? So that's the baseline. Everybody does it. We should be able to get static code analysis. We should be able to understand what's going on and what do we do next. So let's go ahead and maybe what we do next is convert this with some artificial intelligence or machine learning, or whatever you want to call it, right? So I'm going to go here, and I have multiple Visual Studio codes here, so that's going to be fun demo. What I'm doing here is that I'm using a backend. So let's say I'm going to share this, and I probably have to change my keys after I show you this. But I'm using, for example, OpenAI today for this. I have the choice to use Azure OpenAI. I can use Bedrock. I can use DeepSeek, Google, whatever sort of large language model I want to use. I can host it on something locally. And like in our local test, we use Llama 70B, which runs on our OpenShift platform. So the Red Hat OpenShift container platform, we run on that. And then we can basically have more like a private sort of system, right? So then nothing is being going out. And a lot of people that I speak to say, hey, I want my private AI, but obviously private AI has some cost to it. But yes, it can happen, right? So that's what I'm doing. I'm using OpenAI here. What I'll do is I'm going to start my server. And once I start my server, it's going to try to make some verification checks that, hey, this will work with OpenAI. The next thing I have done here is that I have in my configuration, as you see, it's a cool store app. I'll go that in a bit. I have selected certain, rules, configurations, label selectors, and the label selectors here are telling me that, for example, if I go back into my label selectors, I can say, hey, I'm using, oh, sorry, I'm going to make this bigger again. You can see that my target technology, so my source technology is JavaEE. I'm using JavaEE, and I want to target it with Quarkus because that's the framework I love, even though half of you use Spring Boot, and which is great. So Quarkus 3, and Jakarta E, since Quarkus also supports the Jakarta E library. So I want my targets to be in this space, right? So I've defined them, and then I can also add custom rules, but that's for another demo that I will show you just in a bit as well. So I've created this custom profile for my project. So what is my project? My project is basically an old JavaX based JavaEE application, which has a couple of services. It has a catalog service, which basically is an entire catalog of products, etc. There's an inventory service, which basically is simple. So it's a store. It's called a Cool Stuff store, but it's not the Red Hat Cool Stuff store. This is just an example Cool Stuff store. So you can't really buy the merch there in demo mode only. And then there's shipping service, which is using an enterprise Java bean and the message-driven bean here, etc. So there's a bunch of these services that are being used, right? What I'm going to do now is that I'm just going to quickly check. Yes. Oops, this should not be the case. Anyways, I'm going to run the analysis. Seems like, okay, that's fun. So this analysis is now running about 300, 400 rules and trying to go through the entire process of static code analysis inside the repository, right? No worries. It's good to have some background music. And so it's basically doing the static code analysis. And in the static code analysis, it's finding out things like, hey, message-driven beans are not something you use in Quarkus. So that needs to change. You can't use the add produces. You can't. So if I just type something like JavaX, it's going to say, hey, you have 95 incidents of JavaX. You need to change them, right? So it's basically done an entire static code analysis of my file, of my entire project, telling me you have about 149 incidents which are in your repository to convert from JavaX or JavaEE to something like Jakarta and Quarkus. I'm going to take one of the first services, which is order service MDB, which has roughly about, I think, 15 instances. So at this point, the rule set that I showed you there are about violation about, let's say, 5 of those rule sets here, right? 4 rule sets. And now what I'm doing is that I'm going to attach the context that I got from the static code analysis and send it over to the large language model, right? And I'm going to ask the large language model to make a fix for me. This is different because usually, has anybody used Cursor, Juni, AI, chat, whatever to fix things? Yeah. So in all of those cases, you're chatting with the thing, right? Yeah. Here, there's no chat. We make it more boring, right? So we already figured out what needs to be done, and we call the large language model to start fixing this. And since this is a development build, things can go wrong, and hopefully they won't. But we'll see. So here you'll see that I've created some context. Enterprise Java Beans are not supported. This came from our static code analysis. This was the line that was offending the specific problem. So if I look at this line, it says, here's the problem. You need to fix, please. It goes on detail with each and every. Okay. Lovely. Let's try again. I think my internet didn't work or something. Hang on. Perfect. Okay. Come on, you can do this. Yes. Okay. Okay, the scroll is not that fun. But anyway, so you can see that it starts to generate, the code. It starts to generate the reasoning for the fix. So the reasoning is not the reasoning that you usually see in your chat box. This reasoning is being created through the static code analysis, sending over to the large language model, asking it to give us the reasons for each and every decision that it has taken, right? So now here you can see that it has changed. It says I'm going to add incoming annotations. It's going to have this thing in it. I'm going to use Jakarta inject instead of JavaX inject. So it has all of this different thing, and it basically is doing is converting the entire order service message-driven bean into a reactive messaging, which is in Quarkus. So JMS, does anybody remember when JMS first came to picture? 1992, 93, right? So that's like almost 30 years ago, right? So JMS converted to reactive async IO sort of a thing, right? So it's a complete change of how things are being used. It prints out this entire thing. Let's take a look at it. And it gives me this file, which basically has a patch where I can accept or reject the different changes that I want to do. So I can go back here, go into view mode, and here you'll see that, okay, hang on, I need to make it nicer. I hope you can see it. Here you'll see all the things on the left-hand side that are going red, all the things on the right-hand side going green. And this is a generation done by a large language model, right? So I've used the static code analysis. And let me be very clear, the large language model doesn't understand static code analysis if you worked with it, right? So the static code analysis that we've done, we are able to create the hints and everything from it in order to actually get the fix. And the way we get the fix is not just sending in over the whole file, we are doing it in multiple stages. And once that's happening, we are also processing that output as well. And I'll come to that, how that works, right? So here you can see that it has converted message-driven annotation to application scope. It has converted the JavaX to these two nice imports. You can see that it has at incoming order. So if you've used Quarkus, when Quarkus small-ri reactive messaging uses the at incoming annotations, which means that now it can process the topic orders from, let's say, a Kafka queue or whatever, if the application properties is set correct, right? So now you can actually start doing it in that way. You also see that it changes the exception, and this is all pretty much controlled, right, in the way we do it. So this file gets changed. I'm going to take another example here. So I'm not boring you. If I'm boring you, please do tell me. Then I'll try to just burn my demo somewhere. So now I have a shipping service, and if I look at the shipping service, it is an enterprise Java bean. It has a remote annotation, stateless annotation. It has some really, really funny logic here, which I don't know, but kind of makes sense. Less than 50 do this, less than 25 do this. I hope nobody writes code like that anymore. But anyways, so I'm just going to say, okay, these are 4 incidents. Get me a RAG solution for this. And we call it RAG solution because you do not need to fine tune the model to do this, right? It's a very simple thing. We're basically using things like few shots. Have you heard about few shots? Anybody experienced that? So few shots is like telling the large language model, this is how a fix could be made. So you're kind of giving it some examples. So we're able to give it some hints and examples, and it then understands how to do this. And again, in many cases, if you were doing this migration yourself, you might end up asking the chatbot 3 times, 4 times, even 10 times, if you're as worse as I am, the same question, and it might not give you the same result. What we're able to do with this is we're able to guide that result the way we want it out, right? So using RAG, of course. So here you'll see that, again, the same view. Let me open this up. It changes the code that we needed to change, right, specifically, and we create a patch for it. So I could accept this, and I could start going on with my migration. Any questions so far?
In your previous example, you're throwing a runtime exception, and if you look at SonarQube, it will tell you don't throw a generic exception, but it doesn't point that out. So it's like, yeah. So does it apply the Java code analysis as well, or is it just the migration part?
It will. So when you talk about best practice, obviously best practice could be, well, the code that I've shown you is not the best code in the world as well, right? So it's just a demo code, and actually it's a legacy code that some of my colleagues wrote like 15 years ago, right? So, or 10 years ago roughly. So it is legacy code. It's not written in the same way. When you change it, it purely is on the rule sets that we have that define what this is. I'm going to get to the later part of the demo where you can actually define such constructs as well to make sure, because if you were doing this for one application versus if you are able to apply this to 1,000 applications, that's the kind of tool that we're building with Conveyor. We want to be able to learn from your migration process and apply that to the rest of the applications as well.
Like, rather than you having to specify this knowledge is already available, for example.
Yes. Yeah.
So like shouldn't have to really specify the things that are already there. How do you deal with that?
That is true. So that's pure. Again, that purely goes on the rule set. So if the rule set will define a certain example, or it will be the certain model that you use, different model will give you different generation. At that point, SonarQube does it differently.
Can you import tools like SonarQube has some rules? Can you import rules from other tools like Sonar?
You won't be able to import rules today, but you'll be able to create your own rules, right? So there's a differentiation, and that's a very interesting point. I feel like in the industry, we all are having our own way of writing rules. So maybe there's something interesting in the future that we can all do about. But yes, importing something else might not be the thing we do right now. I can write you a. I can write a nice CLI for you. You can convert from Sonar to this using LLM again, right? So just yeah.
Are you simply providing hints to the model, or where are you providing the example?
In the large language model, sorry, in the message. So here, for example, this is the string interpolator example. It kind of gives some. This is the few shot example. You see the impact. You see the fix. I've gone a bit more deeper here with this rule, but different rules will have different sort of hints that are attached to it. So rule crafting is not like it's not extremely simple, and it's not very hard, but it's specific to your use case, right? And that's why I say, like, if you do this for one application, you maybe have let's assume you have a proprietary framework or whatever you want to call it, a framework that is not openly available. Today, if I ask the large language model to convert applications to Quarkus or to Spring or Jakarta, they're quite good at giving me good results. But what if you were using libraries that don't exist in the outside world or are behind paywalls, etc.? then you have a problem because you can't convert them so easily. So by creating your own rules, you can find that pattern and do it. And then let's say you have like 500 applications that use a specific logging framework. You change that and you make an acceptance in this tool, and I'll show you how that works in Conveyor. Then you'll be able to apply them to the rest of the 500 with the same fix as well. So you can define your practice as well as to how it should be deployed across. Yes.
So you said under the covers it's using the OpenAI models.
Right now in this demo, but it can use any large language. Yeah.
But so I'm surprised that OpenAI didn't give that improvement. Or are you are you restricting it to your few shots, or is it a combination of what OpenAI tells you and what you specify?
Something we can look at it right after, I think, because then I have to go into the Git repo to look at the rule, what it's stating. But I would assume that this is what didn't come out, right? And that could also be because I'm using a model maybe which is not doing that exact thing, right? So, but we can take a look. So it's true, different models will generate different things. And this is a very interesting question. Even though I'm working with a project that actually does this, I can tell you that it's not easy to live with the fact that things might be generated differently. And that's something we just need to learn. In a migration process, you are maybe on a branch and you can practice and you can kind of turn around things, etc. But the point is, can we bring value to you, right? That's what it is. So, but let's take a look later. Don't let me go without that. So so here I'm just going to jump into the slide again a bit. So what the idea about this is to, okay, somebody can check out the code, they can configure targets, and targets could be Quarkus, could be Camel, could be Spring Boot, Spring Framework 7. We don't specify specific frameworks. We work on these frameworks to build rules ourselves as well. So you can configure the targets, then it will do the static code analysis. Once it does the static code analysis, we use that static code analysis as the context for the large language model. Sure, you can build this yourself too. I'm not saying you can't. You can actually sit down and start doing it. Obviously, you'll hit some roadblocks, and that's what it is. And that's what we're trying to make sure that we have an open source community where we can work with this and make it even better. Once the contextual fix is received, you would then get a patch from it, or it will generate a patch, and effectively we want to say migration is complete, right? But it's not as simple as that. There's a couple things that happen there. Yep.
Sorry, just a question. On number 4, do you use project like you have this spec, perhaps break the code? Are there any mechanisms where I use the code and try to see if it works?
Yeah, you're going like 3 slides ahead of me right now. So I'm getting there. I'll show you exactly how what that. Yeah. That means that I'm actually on track. Yes, exactly. So yes, great question, and obviously we've been thinking about these things too, right? So this is how it basically works. You have the RAG, we have prompts, we have instructions, we have the context. We put all of that together, and then we send it to the large language model, which updates the source code, gives us the reasoning, etc. Now all of you might be just awesome Java developers, but not everybody knows about every tool, every framework, etc. So it's important for us to give you the reasoning. It's important for us to kind of lay the map for you. This is the source, this is the target. So we're also doing that in this during this exercise as well. The tool that I showed you was basically a UI with Angular 2. So maybe we can change it, Peter. And then inventory, catalog, cart, orders, payments. It's like a cool store, right? So it's like a monolith. And monoliths are not a bad thing. If I was to convert, and this application right now with all the things, in the end, the result will still be a monolith application, right? Because our tool is not going to break it, even though we can maybe apply some more hard science to it and start doing it. But it's not going to break it up. It's going to still be the monolith. It's going to be in a new framework. It's still going to work, right? That's
lucky today, I guess. Maybe you should.
Yeah, we don't have tests yet. We are getting there. Like I said,
Could be existing, so you could do the migration and run the test on that, right?
we are not doing tests yet. Yes. So that's a very good thing, and that's something we are now looking into is actually doing the testing part as well, right? So because that's important. Like assuming you converted from GMS to MDB, now oof, it's going to be hard to test with the old code. You convert EJB to REST, that's not going to be easy either. So what do you do then, right? So you have to write the test. I mean, as humans, we probably have to do something, but the tool might still be able to do. So now we have the possibility with the question that you were asking. Yes, we can compile, but we should also be able to write test case if we can do good generations as well. If we can figure out that, hey, you changed this message driven bean, and now you can also change the application properties, and you can change the POM XML because of this one change, because this was missing in my last demo that I just showed you, right? It didn't change the POM, it didn't change the app props, for example. So now, because that's the problem, like, okay, sure, this is amazing, I can change the whole thing, and I change it, and then what happens is that it's not able to compile, it's not able to run because it doesn't have the dependency. Maybe me as a developer do not know which dependency it was, right? So there's some challenges there. So we want to be able to fix those challenges, right? So anyways, this was the example I think which we missed, was basically that it changed to the REST, right? The EJB at that point. So that's why testing has basically been broken by now, in other words. So what I'm going to do is that I'm going to go in something weird here, which is settings. And so I'm using, we call it conveyor extension. And in conveyor extension, we have something called the agent mode. And you can see it says experimental, by the way. So I'm going to select the agent mode, and I feel a little bullish. I'm going to select the super agent mode too. So we're just working as we go. I'm going to stop this, and just for the sake of it, for my own sanity, I'm going to just run this again and start. So that should connect, and then just run the analysis one more time. So now what I wanted to do, let's see if it does that actually, because this is literally hot off the press from last night. So what I want the agent to do is not just generate the fix, but understand what the fix is, go into the diagnostics, look at the dependencies, what other problems it actually broke because of this one, and start to fix each and every one of them. Now I could go throughout the whole project to do this, right? So that's the fun part, and also the dangerous part, I think, in a way, because the beautiful thing about code generators is, and I might be very people might not like what I say, but I'll just say it, that code generators are awesome at writing a lot of code. So the problem with a lot of code is, once the lot of code is written, you don't know if you want to take it to production in 5 minutes or 10 minutes or 1 week until you've actually read it and you understood what it actually did, right? So there are a couple of caveats there, but so from an agent perspective, this is what I wanted to do, and then I will have the option to accept and reject fixes, and as soon as I accept and reject fixes, it should be able to do more for it, right? So I think the analysis ran. Am I in the wrong? Yeah. Okay. Cool store. There. My windows are playing with me. Okay. So now I'm going to take the message order service MDB. I'm going to say get rack solution. Is going to go for a solution. And up till now in our previous build, what we were doing was that we would take when the tool, when the large language model would come back with a fix to us, sometimes we even heard messages from LLMs, different LLMs, that hey, it's unethical to migrate a JavaEE application to Quarkus. So he's like, okay, that's interesting. Never heard that, but okay, we'll take it. So, so now you see that the analyzer will run as soon as I accept it. And come on. Okay. Maybe I did not refresh it. That is fun part of doing demos. Hang on a second. So somehow it didn't go back. Let's try again. One more time. We'll see if that comes back. Otherwise, I'll just skip. So what I was saying, like the response from large language model could be like weird, like it might not even be code. So we have to sanitize that response. Once we sanitize that response, we want to be able to do a Maven compilation on it, and then run some sanity tests on it, right? Does it actually fix the issue that we actually send it to it? Does it match, etc.? Does the context match? There's some basic checking that's done there. There's a planning agent that basically plans all of this. So what it will do is that it will create a plan for the migration, and as soon as every next step that it will start to take, it will start to kind of take that into consideration as well. We're using Visual Studio Code heavily here, as you can see. We're using the diagnostic tooling inside Visual Studio, the tool system, whether it's Maven, whether it's file system. So we're basically staying within the same ecosystem and doing it. So it seems like that. Let me just take a look. I think I have a little failure here for some odd reason. Yeah, it's somehow not able to pick it up, but at least you get the idea from the presentation, right? That's the goal that we are into, and that also pars with how you see agents today, whether it's been Juni or Cursor or whatever. Is the way they work is once the output comes back, they're able to test it, traverse it, and go back to it. And so the next question for us in the community is to say, okay, can we generate unit tests for this as well, so that we can actually sanity test it? You converted a shipping service from EJB to REST. Now, can we actually, unit test it as well? So you have some boilerplate testing in there. Yep.
Unit test, OpenAI or ChatGPT will generate a unit test as well for you. The challenge is to use the existing unit tests and migrate them as well.
Yep. Yeah, of course. Yeah, that is part of the structure that it's already built. Yeah.
Yeah, I was just going to say, probably saying it, you were saying, if you're writing new unit tests, then you have no way of actually proving that you're doing exactly the same thing that you did before.
True.
So you kind of want to make sure that you've got those tests in
Yes.
place beforehand. So does it allow you to sort of get tests in place before, so it can prove that it does the same thing before and after?
Yes. So there are two. Obviously, I'm thinking more from an implementation perspective here, but the short answer is yes. The longer answer is that yes, you'd be able to migrate your test cases or unit tests to the newer frameworks, libraries, and working with that. The second aspect would be yes, even if it did generate something, it would miss something, right? And so the 90, you could say, okay, it will do 80-90% of the work that I wanted it to do, but there will still be new things that you have to test or check, like the EJB mocking or whatever might be very different than what REST is, and that's a different, maybe perhaps. Can we do it? Perhaps. I'm not saying we can't, but how will we do it? I don't have the answer to it yet. But yes, from an agent perspective, when an agent solves a problem, at least it should be able to write the basic boilerplate code for the actual result, to be sanitizing it for you as well, to saying, okay, this is the things that I've tested, and this is how it looks from a testing perspective as well. But they're two different things, if you understand what I mean.
Yeah, I mean, I'm also just thinking, when you go back to the agent either exception or objective, that's kind of like something that it could take into account.
Yeah.
When it decides, make that decision of does it pass test? That it did what it did before.
Come on in, come on in the community and do some more, work with us. We can figure that out. Okay. No, that's good input. Yes, thanks. That's a very good point. I have to think how that's going to work, so I don't have the full solution to it. Another thing that we've implemented in the latest build from last night again is a solution server. So what we want to achieve out of the solution server is that when you actually migrate or do a migration step, we can record it. So the next time when it needs to do the fix, it is already within the system and it can hint to the large language model how you want to fix it. Something like a certain exception framework that you might have written yourself, and you don't want the generation to be the same, or a logging framework, etc. You want it to be different, and the large language model doesn't know about it. So you want to be able to give some hints to actually to make it do that, right? So let's go ahead, and hopefully this should work. So we're gonna stop this guy. And I have a solution called the inventory management. In this inventory management, I have an audit library, and that's just a logging library. So what I'm going to do is that I'm going to ask the large language model for a fix, and then I'm going to ask it to basically add my hints to it as well. I need to do certain things before I do that. I need my database, because the database is going to store stuff. So I'm just going to quickly check that my database is empty. I'm using Postgres, as you can see at the back end, and I'm using Adminer as the the UI. So it's a nice UI to demo at least. Then what I need to do is I need to start my what we call the solution server, and I'm going to do that. I'm using Python here for this MCP server implementation that does that. So that server will start to come up. I want to be able to go again in my settings, and I have to change what I did with the agents. Conveyor agent. I think super agent failed me today, but we'll figure that out. I'm going to enable my solution server, and that's pretty much it. So I'm going to restart the extension and restart my solution server. Let's see if that works. Yes, solution server is up, and I start it up again. And here you can see that it's telling me you have a file system audit logger that needs to be converted to a streamable audit logger, right? So it has this sort of analysis already done. It points out a particular file here that, hey, this is the file that you should be changing. And then I want certain more changes to happen and not just this one. So what I'll do is that I'm going to ask it to give me a solution from the large language model, and hopefully no disconnects. It goes in, you can see its reasoning. It looks at all of the stuff. Okay, there are import statements I need to change, Here's the kind of file that I want you to change. And it is rolling in. Come on, internet. So it's generating, and this is streaming the responses. So that's why you see it's coming like this. It's not coming one file at a time, right? So it's streaming the entire response. It's going to do that. It's a long file, but while it does that, I'm gonna take some code here, some very cryptic code about logging, and I'll show you that. Which is, so we built like a library that is internal, that is not known to large language models as of a couple of days ago, because since it's on GitHub, it would be known as well. But so it's just a library to demonstrate that if you want to change something, what we use. So it has made some changes. You can see that it says, hey, because I'm changing the import statement, I also need to change this. But then I decide while I'm doing this that, hey, I don't want you to do audit configuration like this. I want you to change it into something like this, right? So make it an audit stream, etc., etc., because I'm using a stream audit logger now. Do that. So I'm just going to do that. Save this thing. Go back here. Say I accept this change. So now it's going to basically take this change and put it into my solution server. So if I go into my solution server and I say select Kai hints dot text from Kai hints, so you will see that it has created a hint already in the system. Now the default static code analysis said something else, right? And if you follow me, I'm actually adding extra code during the migration process. Now it has stored that for me. So when I go into something like another another application, which might be using the same library, then I should be able to see that it should have changed. So when I will try to get a fix for these things, it will show me that it was already accepted or rejected, etc., etc., right? So it's able to kind of detect, because when I send the so if I go here, go into my developer, where's my console? Okay, hang on. Let it finish this. So what it's doing, let me recap that. So basically what's happening is that the scenario is that, okay, large language models can do awesome generation, well, awesome or not, but we can do static code analysis, we can do some generation, but once the generation is done, we want to be able to change that generation, and that generation has to be saved internally with us, and next time we want to generate again, we make the change with it, right? So now when the next time the code generation will be done, it should take the latest hints that we provided it. This way we also can actually have matrix. So in a project, for example, if you are having a project where you hundreds of your applications are using the same logger, then someone in the team rejects that specific pattern that you introduced, and someone accepts that pattern as an example as well. So you'll be able to see how many accepted it, how many rejected it, as an example as well. So that's the idea of something with a solution server. It's a model context protocol that we use. It basically is using the static code analysis, it's using the database, it's sort of putting all of that together and then using the large language model for it. The difference, what's the difference? The difference is that the standalone server is basically just generating what's based on the static code analysis and based on the rules that we had given it. And then let's say you have an exception, like you had an example. You don't like the generation the large language model did. You want to change that generation to what you want. That's where the solution server comes in. So it's able to then record that for you and then push it out for every next time when you're generating as well. It's a good way to sharing with teams. It's a good way to have patterns and practices across all of them. So it's not just chatting, right? It's a lot more than chatting. Why are we doing Conveyor AI? We're doing Conveyor AI because we want to improve the economics of migration. That's why we're doing it. The reason we're using large language model is to introduce the way that you can actually speed up your migration process. It's not Copilot, it's not Cursor, it's not Q, it's not Super Maven, whatever tool you want to call it. It's not a chatbot, it's a guided experience. I value that over a chatbot in many ways, even though I can use chatbot to learn things, etc. But when you have a guided experience, you have a guided flow to a guided end, right? And we want to be able to have that end. And that's what this does. So it combines static code analysis with the context and with the large language model. Yeah.
You said it, the audience, other large companies with huge legacy where you can essentially repeat the same process to just migrate a lot of projects quickly.
Yeah, that's true. And even though I think that we in the community will create way more rule sets as we go forward, and you'll be able to use them. But yes, if you're just doing a one-off project, maybe there are certain rule sets you will need to. But for Quarkus, we have use cases for Oracle JDK, Open JDK, for Spring, for Spring Framework, for Spring Boot, migrations from 5, 6, and 7, for Quarkus. All of these are sort of covered, but then there are things that will not be covered. And that's where if you're migrating, just one app might not be useful, but migrating the major bulk of it, like, that would be helpful. And if we were writing more rules for Spring, it would help everybody, right? So that's what we are focused on right now. So yes, to answer your question, you're right in some form, but also there's something you can do just by single project as well. I see some hands. Yes.
Have you had to deal with, how should I say, volatility? One thing that catches me is they keep changing the behavior of the models in time. For example, just not to go into completely separate conversation, but there's huge cost on their end, and recent models they become really verbose. And in my case, I quite have, it's funny, I had a small scale experiment similar to this.
Yeah.
And what I noticed is the prompts and the instructions and the examples, in my case, they're in MD files.
Okay.
Because it plays very nice with that.
Nice. Yeah.
And some of the models completely freak out given the same input.
Yeah.
And start producing, for example, really verbose code, or just they can't finish something, but others can work. So are you doing anything to keep track of that, or say that this prompt is working really good with this one, with this version, because that's been a constant sort of pain with me. I try to go to the more expensive one, and suddenly write more code.
I have two solutions for you. The first solution is join the community, since you're already experimenting. Second solution is that agentic flow is something that you will use. So the agents, like you mentioned, they're important because they need to validate the responses, they need to recalibrate themselves, and they need to tweak the prompts and keep on changing on the fly as this happens. But yes, we also recalibrate according to that. And one of the things is, we're not saying use one model. Conveyor is an open source project, so we're saying use any model you want, and that comes with a big big lift, because not every model is going to give you. But the idea is then for us to also know as migrators which model suits best. Like, there are models that are good for .NET code generation, but not good for Java code generation, right? So there's going to be difference between how they're trained or what they do. Now, Apple released a diffusion model which can write code backwards to forward, right? So I don't know if you heard, like 2 weeks ago. So there's all these different things that come, and you need to choose the right model for your specific use case. For most of the top models that you will see out there, whether it's Gemini, OpenAI, whether it's Qwen, DeepSeek, Llama, all of these, they work pretty well with this. But then if you reduce the number of parameters, in some cases, the model will start behaving so weird that you will be like, what just happened? But maybe Qwen 22b might perform better than X22 or 70b, right? I don't want to name them, right? So it's like there's these differences that you have to see, and we look at these differences and we understand them, we change according to that, etc. But since you're already experimenting, you should come and hang out with us. Okay, there's somebody else asking a question.
Sorry. We really 5 minutes.
Okay.
We have to.
Okay.
You can ask privately now, but we really have to. Sorry.
Understood.
We have to finish. Yes.
Yeah. So I'm going to finish this. Agentic AI, we already spoke about, that does validation, etc. Also, obviously, I work for Red Hat. We have a downstream product for it, which is called Developer Lightspeed. And the whole idea of it is to be able to use AI on your local private use cases as well, right? With that, I'm just going to leave you with this. I was already finishing, but yeah. So feel free to connect.
are you going to the pub with us?
Yeah, sure.
So if you have more questions, that's the actually reason to go to the pub.
And it's okay if I don't drink at the pub, right?
Yes, I am
Okay,
drinking like the soda with lime. It's not the problem. So
Cool.
yeah, hope you have a good evening. As I said, whoever want to go to the pub,